Hello, everybody. We're going to have fun now. You're going to learn about some electricity. Okay, so the lesson I'm giving you is the same one I use in 141 because electricity is electricity. Doesn't matter what you're doing, whether you're building a satellite, whether you're fixing a car, whether you're listening to me, it's all the same. The opening screen here is scary, and I did it on purpose. I wanted to scare you, right? So don't worry about it. Don't look at that. Doesn't matter. But we're going to go through stuff, and what I'm going to do is I'm going to supplement this with videos. Normally I do this whole thing with the test board in front of me so you can see this stuff as being true. So I'm going to try to integrate that into this when you're actually seeing it. All right? But I do recommend you take notes because that's the way you're going to learn this stuff. Definitely. Okay? So let's move on. All right. So remember chemistry? You all just sat there and went, oh, crap. But yep, this is where it works. This is what it is. So we have to start here. It's the right way to go. So if you remember, you had an atom. And in an atom, you had lots of stuff. So what were the three things you had, right? You had a nucleus in the middle. You had protons, you had neutrons, and you had electrons. Now, do you remember the polarity of things, right? So an electron is what? It's negative. I can't believe you didn't know it, right? And a proton is what? Positive. I can't believe you didn't know that one either. Anyhow, neutrons, what are they? Neutral, right? So we don't care about them. They don't do anything for us, so leave them away. All right, so we have electrons and we have a proton. Now, can we separate a proton from an atom? You've all heard about these super colliders they have in Europe where they try to crash atoms together to separate stuff. Well, that's what it takes to separate a proton from an atom. And I don't think we have that capability in a Buick. All right, so protons don't do anything for us. But we do have electrons. Now, electrons are those little blue things you see hanging out on the outside. Well, it turns out that the electrons at the outer band, the outer valence ring, are the ones that have the ability to do stuff. And what do? They give us electricity. So electrons are electricity. Electricity is the movement of electrons. All right, so those are the ones that we are concerned about. Now, when we look at these things, you can see we have these rings, and they're layers. And in an atom, if you remember from elementary school, they fill up and they move on, and they fill up and they move on, and they fill up and they move on, and they want to complete them, and that gives it a stable shell around the nucleus. So the outermost one, this one out here, that is the outer valence ring, and that's the one that's the player in this. Once we fill up a ring, it's happy. It doesn't want to share. Okay, so it's only the outer band that gets into the play. If we have some, we don't mind giving them away. And if we have most, we don't want to give them away. And that's going to define everything that we have here. Okay, so we're going to start with conductors. Now, when we have a conductor, that outer ring that we talked about has 1 to 3 electrons living in it. Right? 1 to 3. The whole thing about having 1 to 3 is you're not really attached to them, so you don't mind giving them away. And the movement of electrons is electricity. So these are things that support the flow of electricity. If we have an electron and we want to give it away, it goes. Now there's something funny that happens. What happens when a negative comes next to another negative? Right? They repel each other, right? So now you have this electron that leaves to go someplace else, and it goes up and cozies up next to another electron, and what's that one do? It runs away. Now we have electricity. We have the movement of electrons. So conductors support it. Things that are good conductors: copper, That's what our wires are made out of. Gold, right? Who here has bought gold HDMI cables? Well, the fact of the matter is, it works no different than the cheap ones that Amazon sells, right? But gold is prettier, so you think it works better. A digital signal is a digital signal. Either you got it or you don't. All right, so anyway, gold is an excellent conductor. They use it on airbag terminals. If you look at a computer, the ones that are specific for the airbag are gold plated because they're better. But naturally, I think we can see why we don't have gold wires in our cars. So aluminum is good and steel is good. Now, if you look down here below, and I can even zoom this, right? We have copper. Now, if you look at this copper thing, you see it's got one electron hanging out. So that electron is ready to be given away. If we look at gold, gold just looks better, right? It's like more bedazzled, more layers. Therefore, it's really good. Obviously, right? It just looks good. Anyway, it still has one electron hanging outside. So, happy to give it away. If we had two on the outside, well, it's got a friend on the other side of the whole thing, and it doesn't necessarily want to leave him. But if we persuade him enough, he'll move. And if we have three out there, well, three is an odd number, and one of them is going to beat it before the rest of them. So all of those things are all things that support the flow of electricity. If an electron will leave, then we can have a party, right? Electrons move, electricity flows.